Good afternoon once again, everybody. Thank you so much for everybody to take your time out of your schedule and then joining the webinar SIMULIA Solutions for Trades. Before the webinar subject starting, let me give you a brief introduction about who are we, EDS Technologies. EDS Technologies Private Limited, EDST, is the largest CAD/CAM CAE and real-time visual simulation solution provider in India. With over 2 decades of experience in various industries, we enable companies in the aerospace, automotive and supply chains, industrial machinery, high-tech and electronics, railways, infrastructure, consumer packaged goods, engineering service providers, defense and research verticals to achieve their business goals. We are established in 1995 and are headquartered in Bangalore. Our company operates with its direct presence in India, which are into Chennai, Coimbatore, Gurgaon, Kochi, Hyderabad, Pune, Mumbai, Kolkata, Noida, Ahmedabad, and Nagpur. We have the largest customer base in Indian market in PLM, ERP, and visual simulation business, and have financially partnered with more than 1,500 customers in various industry verticals. So we have Mr. Nagananda here, our Senior Application Engineer in SIMULIA Solutions. So I will be handing over the webinar session from here on to Nagananda. Please hold on to your questions if you have any till the end of the webinar. I will be asking the same to Nagananda and he would be more than happy to answer you all. Thank you so much, and here is Nagananda.
Yeah, thank you, Archana. Thank you all for joining this particular webinar session on SIMULIA Solutions for Brakes. In this, we are covering about overview, primary workflow, advanced workflow, customer reference, and technical resources. Having said, we are also going through some set of tools which I am going to introduce in the first part, and later on we will go into the actual webinar presentation. So here we are speaking about simulation powers innovation. That means which reveals the full potential of realistic simulation, which includes the conceptual optimization, a detailed design optimization, a fatigue and durability analysis, as well as the process integration and automation. In this tool, as I discussed, we are discussing on 4 different softwares. In this presentation, we are discussing on 4 different softwares, which is Abaqus, Isight, Tosca, and Isight. Abaqus, which is a continued technology in the leadership and which is used for innovation purpose, which is a part of SIMULIA and which will be having a preprocessor and post-processor in the form of Abaqus CAE, complete Abaqus environment, as well the solvers like Abaqus Standard and Explicit. In Isight, it is a multidisciplinary optimization tool which is used for application components and process and design analysis, and Tosca, which is used for structural and fluid flow optimization, which is used for topology, sizing, shape and bead optimizations, as well Isight for fatigue analysis and durability. With the culmination of all 4 softwares, we could able to run the analysis. So here the QAX, which is extended CAE for interactive purpose, into a single graphical user interface session to work on either on Abaqus CAE, Isight, or Isight or Tosca at a time, and the solver tokens, which can be QXTs, which are more powerful tokens to compute the analysis that we give, like Abaqus solver, Isight processor, process execution, Tosca optimization task, and Isight for durability and fatigue related analysis. For those who are new to Abaqus, I take some time to explain these things, a few slides. This Abaqus, as I described, is a unified FEA, a tool, finite element methodology tool, which is used for CAE, that is pre-processing and post-processing. which also includes in the pre-processing, which also includes the graphical interface, a modular and well-organized interface, which is used to like import the models, add the material property, loads, boundary condition, assembling, meshing, inbuilt a strong meshing tool, as well as contacts, applying the contacts and convergence constraints, and also submitting the job. So once the job is submitted, we have two sets of solvers. One is Abaqus standard, which is used to do the static and structural dynamic analysis, linear and nonlinear analysis, a wide range of multi-physics procedures, which includes static stress displacement, dynamic analysis, mode-based linear analysis, heat transfer, coupled field analysis, acoustics, etc. Similarly, explicit analysis, which is used for like high-speed transient dynamic events, are also suited for highly nonlinear quasi-static analysis, or in terms of range of solution procedures, which includes thermal analysis, acoustic structural coupling, coupled Eulerian-Lagrangian, etc. And the same CAE will be again used for post-processing in terms of visualizing the results. And the second tool which I was discussing is a fatigue analysis tool, which is used to find the life prediction, to predict the life of the component or the durability of that particular component, which takes the data in this workflow, which explains how it works. It will take the output data is file from the CAE, and again the material will be added, again the load data or road load data will be applied and further analyzed based on the stress approach or the strain based approach to get the results. That is like how it works in FECF. Coming to the third product, that is Tosca Structure. Like for example, if it is structural optimization, in order to increase the stiffness and decrease the weight. If it is sizing, again it is used to reduce the mass and optimize the shape thickness. In terms of structural shape, Tosca Structure shape, it reduces the stresses and increases the durability. And in Tosca bead, which increases the stiffness or eigenfrequency of the sheet metal component. And again, the final product that we are using is Isight, which is a framework software package that is used with the existing SIMULIA codes to build and execute SIMULIA workflow. Here you will be having a core, a premium, and a technique. So it's a coat hanger like structure, wherein which you will drag and drop the particular feature from the process components and application components in order to further build that model to get the analysis. For example, design of experiments or optimization or Taguchi, Six Sigma, anything which falls under technique sector, so that can be like utilized here to do further analysis. Let us come back to the original the model and the presentation of which includes the overview. Like for example, here in this particular agenda, like we are following that we will be looking into some of the primary workflows which are like commonly used to analyze a caliper break. And which includes like a primary workflow would be like a durability analysis of caliper brackets, and housing or caliper seal analysis, and contact pressure distribution analysis that we are going to work on. And also in the next we will be looking into some of the advanced workflows which are performed by some customers, but could also like benefit some others also. And like for example, like thermomechanical analysis, brake squeal analysis of caliper brake assembly, as well as optimization and life estimation of caliper brake assembly. Finally, we will discuss about resources available in our knowledge base. First, we will discuss about the classification of the brakes, and then we will proceed with as I discussed. Like in this particular slide, we are discussing about the frictional brakes which are most common types of brakes. As the name says, frictional brakes, like there is a friction between the two surfaces, is used to stop or slow down the motion. And frictional brakes are classified further into like drum brakes and disc brakes. Again, in the disc brakes, it is floating caliper and fixed caliper. Let us discuss about the disc caliper brake, which says about the disc brakes are quite common in the passenger vehicles that whatever we are using, and the drum brakes are sometimes used in rear wheels to reduce the cost. They are like cheaper and lighter. The reason is that the braking affects the front wheels more than the rear wheels, and the drum brakes provides better stopping performance when it compares to the other one. And also further, the disc brakes have a better heat dissipation capacity, which is one of the most important aspect. And the disc can have holes drilled into it to aid in heat dissipation, but this can lead to issues with stiffness and durability. This setup sets up an optimization problem that would be like discussed in the later slides. So again, we are like covering the primary workflow, which says about the primary workflow, which involves the performance evaluation test at component and sub-assembly levels. At component levels, we will like predict the durability of the part, like caliper, brackets, and housing. And also the sub-assemblies and assembly level, we will do caliper seal as analysis to predict the seal response and contact pressure distribution analysis, which will be like carried out to measure the contact pressure distribution during the braking. And we can also predict the pad wear pattern in the test. The durability of caliper bracket, here in this particular slide, we you can like the caliper bracket is critical as it takes all the frictional forces during the braking, and the caliper bracket also not yield or overly deflect during the braking. And also the brake technique is converted into equivalent pressure load and will be like applied on the abutment regions, and in this analysis the flexibility and the durability of the bracket will be like measured. The main point is that analysis on brakes need not be like analysis always at the assembly level. Even the component, whether the caliper bracket or the seal or the disc itself, can be subjected to durability or durability studies. So all those things are captured in this slide. Once the analysis is completed, we will be like we will check for the stress distribution. You can see the stress distribution as well, and especially we will check for the hot stress like stress hotspots, as this will affect the durability of the caliper. And the deformation of the caliper will be like measured at critical points and will be like compared with some of the standard experimental benchmark values too for compliances. The caliper should not deflect more than the particular value at this, which will indirectly increase the brake response time. So later on, this results can be like further used for fatigue life estimation. On this, we are going to like look into in the coming slides. And this slide will explain like the caliper seal, besides preventing the leakages of the brake fluid, also retracts the caliper piston after braking. The piston retraction depends on the profile, so that like the profile of the rubber seal and the groove. Here the caliper piston and after braking, like how it is being used, and the seal is usually the square of the cross section, and hence sometimes referred to as a squill seal. So on this we are going to discuss in the following slides. And also, as indicated in the images at the top, on the right hand side you have some brake applied and brake released. what is the difference between these two, which also like leads to a retraction of brakes after the brake is released. And one obvious advantage is that there is no need to have any separate retraction mechanisms. In the case of wear of the pad, the seal also helps in still maintaining the proper contact. So we'll discuss about the Stool in the coming slides. And again, the results as in the slide is explanatory here. The reference demonstration caliper analysis by considering the housing and the lining as merely stiffness or springs. The springs have been used here in order to represent that. Although not considered in the reference, design of experiment study can be like conducted to study the impact of the different grooves profiles on the seal performance. So we can look into that, and where for analysis, for example, can also be like incorporated in the study of how the difference the grooves profile will deal with the wear analysis. Coming to the next slide, this is a contact pressure distribution slide, which like represents between the pads and the disc is a key to understand the brake performance, and also like such as a thermomechanical analysis, which includes the friction which induces the heat, as well as brake squeal and wear. The advantage of using Abaqus here for is that the same detailed brake assembly models can be like used for multiple requirements, and also like the methodology for brake assembly analysis, which involves the pre-tension, bolt pre-tension and interference fit resolution. As well, in the second step, it will be like establishment of contact between the pads and the stationary disc. As well, in the step 3, it will be like establish steady state rotation and rotational motion. To continue here, like we are more information like the steady state frictional sliding. We can work on this, and we have enough examples available in the documentation, which also helps to like execute this particular analysis. Having said, in the same to continue with the contact pressure distribution, in the first step analysis, the model is brought into the its assembled state, and fastening forces are introduced in all the bolts, and a shrank fit procedure is used to determine the assembled state of the springs that secure the brake pad in the assembly. Also the caliper housing and the piston. The second step, the pressure is applied on the piston, and the housing in a static analysis. And the contact between the pad lining and the disc is thus established. So in the step 2, which allows the contact pressure distribution on the lining surfaces to be determined when the disc is stationary, and in its static step of rotational velocity, which is like imposed on the disc as a predefined field variable, and this provides for the modeling of a steady state frictional sliding between the two bodies that are moving with different velocities that can be like considered. And result wise, we can look into this. So you can see the bolt analysis, loading and interface resolution, contact pressure distribution, how it has happened, and the contact pressure distribution when the disc is rotating and with at a steady velocity, when there is a difference in the velocity. And then moving forward, we are looking for some of the advanced workflow, which includes the thermomechanical analysis of the brake. Here, the heat generation is due to the friction during the brakes, as has adverse effects on the brakes assembly and leads to the brake fade, like premature wear and thermal cracks. Uneven thermal bands of in rotor leads to the disc thickness variation, and uneven expansion of the rotor, which in turn leads to brake pedal pulsation and brake torque vibration (BTV). So the objective is to determine the temperature and thermal hot band locations and to measure the disk thickness. The variation thereby a suitable design change can be made to achieve a uniform temperature band across the rotor. A coupled temperature disk analysis step in Abaqus can be like used to predict the frictional which induces the heat accurately. And in this temperature profile, thermal bands and thickness variation results can be displayed, and you can find the contours for the two different designs, which is for the two design. Like center, we have a temperature contour across the disk for the two design, and also the disk thickness variation for the two designs on the right hand side. Coming to break square analysis, which is a major analysis that usually the brake analysis brake industries and brake lining and allied industries works on. So brake square is the noise that results from dynamic instability that caused due to the friction between the lining and the disc, and this instability can create noise, which is commonly known as a brake squeal. One possible explanation for the brake squeal phenomena is, for example, the coupling of two neighboring vibration modes. If two modes are close to each other in the frequency range and have similar characteristics, then they may merge if the coefficient of friction between the pad and the disc increases. So when these modes merges at the same frequency, like for example become coupled, one of them become unstable, and the unstable mode can be identified during complex eigenvalue extraction procedure, and because the real part of the eigenvalue corresponds to the unstable mode and is positive, and the instability in the brake system design can be eliminated by changing the geometry or by material properties of the brake components to decouple the modes. And in continuation to the brake squeal analysis, the preceding steps determines the initial stresses in the model and the steady state braking conditions. Here the real eigenvalues are and the mode shapes of the model are extracted, and in this procedure the tangential degree of freedom at the contact nodes at which a velocity differential is defined are not considered. So, and the set of eigenmodes provides the subspace for computing complex eigenvalues, which can be in the next step. So in continuation, the high frequency squeal mode is dominated by tangential motion, which you can find in the example that will be shown in the next page, and also in which the disc exhibits predominantly in-plane rotational action. It is natural to assume that modes with the largest real part of an eigenvalue are likely to be the most unstable one. However, sometimes such modes are over predictions, and unstable modes with lower values of the real part can be actual squeal mode. A preference approach to calibrating analytical models is to start with the experimental data, identify an unstable mode of interest, and look for it almost predicted instability. Here we are concentrating on two plugins. One is CCF and CMF, which is part of we can have in Abaqus CAE, which provides a built-in plugin to view CCF, that is component contribution factors, and CMCF, component mode contribution factor, and this can be availed from the knowledge base, and we can start using this, and which provides a simple way to identify the components contributing to the most unstable modes. And again, the lining wear can be a significant important on the brake square and its performance. Uh, because of the also the which affects the noise generation, between the contact condition between the linings and the rotor, and also the which affects the noise generation. In a dynamometer test or a vehicle test, brake lining have to be furnished before they can be used for testing. Similarly, finite element analysis using an unworn lining profile can generate an unrealistic contact pattern that causes discrepancies in noise prediction. Abaqus standard of adaptive meshing and adaptive mesh constraints can be used to model the arbitrarily larger amount of ablation of material away from the domain. So we can have this in the we have some data available in the knowledge base, using that here the Isight is also used to automate and optimize an Abaqus brake squill analysis. The example used here deals with the material properties of lining to eliminate the brake square. However, the same procedure can be used to study any design exploration or sensitivity study with the Isight for brakes. Here we are discussing about multiple products. For example, to do the structural and thermal analysis, we are using Abaqus, and exploration of design alternatives. So we are using parametric optimization, that is Isight. For example, DOE or optimization can be done. And Tosca Structure, we are using the conceptual lightweight design, click topology optimization to reduce the weight and increase the stiffness. And again, in the shape optimization, to improve the structural integrity by reducing the stresses. And finally, the durability analysis by using the FE safe. I do have a small video AVI, so we'll look into this. Thank you for viewing this film. This is integration of all the four softwares, Abaqus, FESAFE, Isight, and Tosca, and integrated to work on this particular brake analysis. Moving on to the next slide on the optimization and durability for brakes, which says about the structural analysis, which will help us to mimic the stresses and deformation when the brake forces are applied onto the disc. Also, the capabilities of Abaqus in terms of realistic contact is depicted. Then the thermal analysis, which is most important in terms of heat dissipation because of the which has to happen because of because it has generated from because of heat frictional applications, and also which performs for the cooling of the disk. And this way we can like find out the temperature distribution in the disk. And this slide explains about the integration of this model in terms of Isight. You have multiple components, like for example, data exchanger, calculator, thermal analysis, which is done using Abaqus, or the SimFlow methodology, which are included here to like do the optimization. It explains how the Isight is used to integrate the process and to perform parametric optimization. And also during the braking, when a brake disc comes in contact with the pads, so due to the friction, a large amount of heat will dissipate to the disc, and also this accumulates of the large amount of the heat will cause the failure of the brake. So especially when a sequence of brake is applied during a high speed or during descending in slope, or and hence the cooling is critical. And this can be approached by modifying the material or geometry, one option, or in this case the vent holes allows the air to circulate and flow through the disc and helps in cooling. And it is required to achieve the best possible cooling without affecting the strength and the performance. That is more important and critical. And also the different parameters to be validated, which like maybe the varied in terms of number or position or size of the vents for the air circulation for cooling purpose. So here in the brake design with the different parameters are integrated, as I discussed, like data exchanger, which is used for like a Python scripting script has been incorporated. Like there will be certain parameters need to be changed, the parameter values need to be changed, and it is like used in multiple loop here. As well, the calculators to for the performance calculation on parameters, and Abaqus, which is used to do the thermal analysis, and SimCode, which is used to extract the results, Abaqus results in this particular Isight analysis. Having said, we have the results here, which explains about the automatic generation of multiple design and the best combination of the vent hole design parameter in terms of position, the number and size. The overall degrees that is around 30 degrees of centigrade of temperature is reduced while leaving sufficient area for much cooling. The temperature was more homogeneously get distributed, and the Isight, with the help of Isight, we could be able to come up with a much finer design. You can find the results on the right hand side. It has been displayed. And also in terms of conceptual lightweight design, so here the topology is being incorporated. The topology optimization allows to determine the location and the shape of the spokes on the which is carried out to take the severe loads during the brake events. This is achieved by starting with generic design space and material being removed from structural unimportant locations, and the non-parametric approaches, which allows for basically any shape or to be generated, thus finding design that precisely reflects the functionality of the part, taking into account the exact conditions under which it operates. And also the big scale modifications, which are removal of the material, which leads to the significant weight reduction. The manufacturing constraints like rotational cyclic symmetry or demold direction, which proposes design will fulfill the geometrical restriction as well, because of the due to the manufacturing requirements, and even at the early stage of development process. The advanced modeling techniques of Abaqus, which is like non-linearities contact, can be used to in conjunction with Tosca to insecure that the final design respects the real scenarios under which it will operate on. So here the topology optimization, reference and optimum, how the weight reduction has happened from 292 grams to 205 grams, as well as the displacement wise it was 1.1 mm and 0.6 mm. It's all because of the weight reduction of about 30% of the weight reduction, at the same time doubling the stiffness. Stiffness has doubled in that. This has been done using Tosca here, and a nonlinear modeling and the contact has also been considered. That is a plus point of Tosca, which also says about which can consider the nonlinearities like contact, or all three types of nonlinearity can be considered in Tosca structural analysis. Moving on to the next slide, which says about the topology of a shape optimization is applied after topology optimization is to fine-tune the results. In this type of optimization, it helps us to reduce the stress peaks. You can see the stress peaks by slightly modification in the outer regions, so which takes into the account of multiple load cases, meaning the position of the pad and the disc at different places, and also manufacturing restrictions are also considered in this one. The result wise, the outcome is that with slightest change we could able to reduce the stresses by around 25%, is one of the plus point here in this particular slide, which explains you on this one. Moving to the next slide, which says about the fatigue assessment, we could able to we will need to find the durability and the life of the component based on the loading history, and also can accurate prediction of the life fatigue life. The model is set up with the load of about 400 kg, motorcycle plus driver, and also time of 3 to 4 seconds and speed of 45 meters per second, and a stopping distance of 67 meters, and 25 wheel rotations before complete stop for every 1 brake instances, with around 3 lakh braking cycles. In FEM, the brake pad moves from step to step and increment to simulate the load running around the disc, like centrifugal load and the bolt load. And finally, we use FESAFE to evaluate the durability of the brake rotor, since it has to withstand to simulate the load and running around the disc like centrifugal force, and also to predict the service loads, and also the life also depends on the usage, like how it has been used, the tire has been used, the brake has been used. And the FESAFE can also integrate with Isight for parametric optimization, as we discussed, and also in designs changes in case of durability and not as expected. And we have enough case studies and conference papers which are presented by the users, existing users across the world in the respective regional users meets, that can be accessible from the knowledge base. We have that access and internal library, as well technical resources. Multiple examples are available with respect to the thermal stress analysis of a disc brake, or brake squeal analysis, and also sequentially coupled thermomechanical analysis of a brake with a Eulerian approach. So we have enough data available in the knowledge base as well as in the documentation, which is accessible, and also some of the customers' case studies available for the reference purpose. In the knowledge base, we have some articles based on this, like CCF or CMCF, and also bricks well some of the examples which are accessible to the customers and also for the reference purpose. Having said, we have discussed about the four softwares, how it has been integrated in optimizing and utilization of the best design of brakes in the automotive industry. So, as I discussed in the earlier slides, which says about the token systems, like QAX is the common GUI which is used to interact with all the four softwares, and QXT being the number of tokens, solver tokens, common solver tokens which can be used to run the analysis in terms of structural and thermal analysis and answers, or doing the DOEs or optimization in terms in Isight software, or weight reduction, topology optimization, or the shape optimization in Tosca software, or predicting the durability or the life of the component in FE So same set of tokens are used, which are like scalable in terms. If you add the tokens further, you can do the further analysis, and also it is more economical in terms because the same GUI which is used for all the four software and same tokens are used to do any sort of analysis within SIMULIA suite. And also it is simple and the learning curve is fast and scalable. These are all some of the power of portfolio in terms I wanted to like discuss in this analysis, where they have used all the four software and integrated to do the brake analysis. This is what I wanted to present. We request your thanks for listening to me. I request your time for presentations, and we are located around 11 cities across India. So it will be helpful for us to like reach out to you and give a customized presentation and demonstration on the brakes as well, and the brakes liners as assembly, and we can also discuss on the other portfolio pack like includes Isight, FEA, and Tosca apart from Abaqus. We look forward for your kind appointments to discuss at your end. And also, if you have any queries, please let us know. And thanks for listening to me, and over to you, Sue.
Thank you so much, Nagananda. It was a great session. It was a great informative session for us as well as for the attendees, I hope. Attendees, you can post your questions and Nagananda will be more than happy for you to answer them. So we are open to your questions, queries, everything regarding the presentation. Hello.
Hello.
Yes, Mr. Mohanraj.
Ma'am, I have small doubt regarding the Please.
Mohanraj, can you please be a bit louder, or you can even message me if you have any questions, if you have any problems.
Okay, ma'am. I will message you.
Yeah, please text it on the text box. I will let Nagananda know about the query. implement of